Everyone, thanks for checking out the video. Today we're going to be working with positive and negative decimals, and we're going to be adding and subtracting them. So we are going to work with, again, decimal skills, and we're going to apply our knowledge that we learned for positive and negative whole numbers to positive and negative decimals. So we have some questions here that we worked on for the do now, but before we get to those, let's have a good discussion. Here's a question, 13 plus 9.7. Student A solved it this way. Student B solved it this way. Who do you think did it correctly, and why do you think that's the case? That was the discussion we posed in class, and there were some really good responses and some good thinking that was going on and good authentic discussions. It came basically down to the point whether people agreed or disagreed on aligning the decimals. This person aligned the decimals, this person did not, because the decimal would be over here. And then we asked, how can you check to see who's right even if you're not using the decimal method? And someone brought up the point where if I just forget about the 0.7 for now, and if I just treat this as 13 plus 9, I would get 22, and then add in the 0.7, 22.7. So that person made an argument for why this person was right. And then over here, if you look, we have 13, or you can kind of think of it as $13, and then we add $9.70. How could you possibly get a smaller number than you started with? That doesn't make sense. So we talked about the importance of estimating and how we use estimation to check the reasonableness of our answers. So 13.7 is really close to 9.7 is very close to 10. And 13 plus 10 is 23. So we know our answer needs to be around 23. And student B's answer is very close to 23, which makes sense, and student A's isn't. So another way to check is to estimate before you even do anything. Okay. Let's take a look at the answer, the questions now. 2.4, 6.8. Now we know we do need to add our, align our decimals. So we got 4 and 8 is 12, carry the 1. 6 and 2 is 8, plus 1 is 9. And we put our decimal in the middle. Same thing here. We already did that one, so we don't need to do that. That would be really 13.0. And when we put a point here after a whole number, we can add an infinite number of zeros, however many we need for a particular problem. So how about here, 6.8 minus 1.3. I'm just going to do it underneath to make my life a little bit easier. 8 minus 3 is 5. Decimal stays in the same line. 6 minus 1 is 5. So we get 5.5 over here. 21, well, 21 minus 2 point, because this is like 21, right? Point 24. And to fill in this space, we need to have a placeholder. So we put in our placeholder. Now, can we subtract 4 from 0? No. We need to regroup or borrow, however you learned. We get 6, keep the decimal. Can we subtract 2 from 0? No. So we take from 1 from the 2, and we put it over here. So we get 10 minus 8. 2 is 8, and 1 comes over. Our final answer would be 18.6. Great. And again, rewatch these if you have any questions. Can we use what we learned about adding and subtracting positive and negative integers to add and subtract positive and negative decimals? So I'm going to show you something. Is this correct? Can I write this, and does this make sense mathematically? Well, you can think of this as money, right? Someone said in class, money helps them think. All right, well, I think in money too sometimes. I owe someone $1.50, because I can really say that this is 50, right? This is 50, same thing. And I owe someone else $3.50 altogether. I owe $5. So yeah, this works perfectly fine. And you might remember that when the signs are the same and you're adding, you can just add the absolute values together and keep the sign. So 1.5 and 3.5 together makes 5.0. Since they're both negative, we keep the sign because they're the same. You can add those two. So just as a recap, whenever you need, like 528 plus 749.49, whenever you need, you can put a decimal after a number if it doesn't have a decimal yet, and then add in zeros at the end to have placeholders, and then put it together. This one's nice because they're already lined up nicely, but we need to pay very close attention to do that whenever we need. So here is kind of what we've talked about past couple days. If we're adding the same signs, life is good. We can just add and keep the sign. 1.1 plus 2.2, and I'm just using easy numbers to get this point across, is 3.3. Negative 1.1 plus negative 2.2. So I always pose the question like this: can I put these two numbers together? And your response should be yes, because the signs are the same. So somewhere on the side of your paper, 2.2 and 1.1, add them up, and that gets 3.3. However, they're both negative numbers, so it should be a negative 3.3. So again, they were both positive, so your answer stays a positive. They're both negative, and you add them together. So you put them together and then keep the negative sign. Adding different signs, here's where it gets tricky. One's negative, one's positive. Can we add these numbers together? I realize that there's an addition sign here, but one's a negative number, one's a positive number. You cannot simply add those together. So you go on the side of your paper, and if you can't add them together, you must subtract the two numbers. We'll deal with whether the answer is going to be positive or negative at the end. So we get 1.1. Now you ask yourself, is it going to be a positive 1.1 or a negative 1.1? So look at the numbers. This one is positive, and it has a greater absolute value than this one, which is negative. So our answer must be positive. Notice if we did the same thing in this problem, there are more negatives than positives. Or you can think of it as the absolute value of this one is greater than the absolute value of this one. So our answer here would be a negative 1.1. Subtracting, we discuss, is difficult when dealing with positive and negative numbers, right? So we always like to rewrite the problem whenever possible. So this one becomes 1.1 plus, it was a positive 2.2, so then it becomes a negative 2.2. So we just turned this problem right here into this equivalent problem. We rewrote it into this method. We're no longer looking at this problem anymore. We're just dealing with this one. It's an addition problem. Can we put these two numbers together? No, we can't, because the signs are different. So if we can't add them, we must subtract them. 2.2 minus 1.1 is 1.1. There are more negatives than positives, or the absolute value of the negative number is greater than the absolute value of the positive number. It must be a negative. Same deal here, right? We need to rewrite this as 1.1. The subtraction becomes an addition. The negative 2.2 becomes a positive 2.2. Isn't that so much easier to do than this problem? Sure, it just gives us 3.3. Okay? All right. Then we worked on some problems, which ended up being your homework, and that's pretty much it. There are tons of other resources on the internet. I encourage you to check them out to help you with your homework, or rewatch this video, any parts that you need. But again, it's just like working with positive and negative whole numbers, except they're decimals this time around. So you take what you already knew from the previous concepts and you apply it in the decimal world. Always look, Are the numbers the same sign? Are the numbers different signs? If it's a subtraction problem, turn it into an addition problem and go from there. Thanks for watching.